Okay, guys, let's see if we can get this one done very quickly before I have to get off here. When a kid drops a rock off the edge of a cliff, it takes 6 seconds to hit the ground. Okay, there's sentence one. When he throws the rock down, it strikes the ground in 4 seconds. What is the initial speed of the rock being thrown? Okay, great question. So it's talking about, the question actually covers the second sentence. So I'm going to make two columns here. I'm going to divide my paper in two. All right. This side is all going to be about the second sentence, and this one's all going to be about the first sentence. Okay. All right. So the first sentence, it says that we have a time equal to 6 seconds. Okay, does everybody follow that? It also says that this rock is dropped, so you know when you drop something, your initial velocity is 0 meters per second. Don't do that. It's just trying to make this. Okay, whatever. And then last but not least, what pulls this rock down? Well, we assume we're on the planet Earth, and you can have a pretty good physics career by always making that assumption. And when you're on the planet Earth, gravity pulls you down by an approximate average negative 9.81 meters per second squared. And that's an approximate and an average. Okay, so that's what we know about the first one. All right, but the question's not over the first sentence. It's over the second sentence. So what does the second sentence tell us? Well, it tells you this, that time equals 4 seconds. Okay, so when this rock is being thrown, this one, it's being dropped. And this one, it's being thrown. Very important that it's different, guys. And these numbers, they can't cross the line. Or can they? What do both these have in common? It's a good question. Now it says, what is the initial speed of the rock being thrown? It's asking for your VYI. Now, why do you say, you might be saying, Mr. Shaw, why your VYI? It's asking for speed. Well, remember, guys, speed is the absolute value of your velocity. So it's asking you to find your VYI and then take the absolute value of it. And that's going to give you your initial speed. So we're going to have to get this, the initial speed, and to get that, we have to take the absolute value of your initial velocity. But whoa, Mr. Shaw, we still don't know anything about this. Well, here I am to deliver some more good news. Remember, guys, what in fact pulls this object downward? Gravity. So this is going to be very, very similar to some extent what we've been doing before. Gravity is going to pull this object down. Even when you throw an object downward or when you throw an object upward, gravity always pulls it down. Okay. Now the next thing, guys, is you have to remember this is the same cliff. So if it's the same cliff, the same building, the same circumstance, you're going to have the same height. Both rocks are going to fall the same height. So if you get your dy from this side, you can transfer it to this side. Okay? So let's find it over here. You have t, vyi, a, and d. I'm going to just give you guys the formula. Hopefully you guys know what you're going to be doing. You're going to go dy equals vyi t plus 1/2 AYT squared, and you're simply going to plug in dy is your unknown, so let's leave that as a variable here. Dy equals vyt, which is 0 meters per second. I love my parentheses. Times time plus 1/2 times negative 9.81 meters per second squared. T squared. Now this term is going to cancel out. We're left with dy equals negative 4.905 meters per second squared. And I left something out, guys. I'm going to put it in now. We know the time. The time is 6 seconds. And when we square 6 seconds, we should get 36 seconds squared. Okay, sorry I didn't put that in there. I was running out of space. And now we have this, and we can just simply plug this in your calculator. You're going to get negative 4.905 times 36, and everything should cancel out, and you are going to be left with a very nice answer of a dy equal to negative a dy equal to a negative 176.58 meters. And what we should realize, guys, is that this value right here needs to go over here. written a little sideways, doesn't fit in with the original lines, but now we've got three things. Now we know three things. We know the time, the g, and the dy. We can now solve for our initial velocity, like I said. Well, how can we solve for this? Same exact formula, guys. This has everything we need and everything we're missing. So, let's go negative 17, or gosh, I keep saying 17, 176.58 meters equals your VYI times your t of 4 seconds plus 1/2 negative 9.81 meters per second squared times, I'm going to put this down here, I'm going to go times 4 seconds squared. Sorry, I ran out of space. So what we should see is, I don't want to move it. I'm going to give myself a little bit more space. Negative 176.58 meters equals VYI times 4 seconds. And then this is going to be squared and multiplied by 1/2. So you're going to get plus negative 4.905 meters per second squared times 16 seconds squared. And then this right here, you're going to multiply this. 4.905 negative times 16, enter, should give you a negative 176.58 meters equals VYI 4 seconds minus, because it's just going to be minus 78.48, and we're going to get meters. So we're going to subtract from both sides. I'm going to subtract, or I'm going to add this to both sides, add it to both sides. So so when I add it to both sides, 76.58. When I add this value to this value, I should get a negative 98.1 meter. And then I'm going to divide both sides, because you see this is equal to VYI times 4 seconds. And I'm going to divide both sides by 4. Divide by 4. And that's going to give me a VYI, I'm almost done, equal to negative 24.525 meters per second. Now it's negative. Now remember, your initial speed, you take the absolute value. So I'm just going to do this. And now I've made this initial speed. Took the absolute value. Okay, great.